Let's have a look at circles then, a little intro to circles. The circle is the locus of a set of points which are a fixed distance from a fixed point. So you've got a fixed distance r, the radius, from a particular point, which you can label P, which is deemed to be the center, and then we end up drawing a circle around that point, don't we? All these points are a fixed distance r from the center C. So if we give the center a distance coordinates AB, and we denote the radius as r, then we can write down the equation of a circle, can't we? Because we can simply use Pythag. So the difference in the x coordinates, so x minus the a will be the x difference, that squared, plus the y minus the b coordinate. There's the y coordinate there, so y minus b squared, so that squared plus that squared, I've written them down here, must equal the longest side squared by Pythag. So we get this equation here, standard equation of a circle. And if we have an equation in the problems that we have in this form, we can simply read off the center, which would be AB here, and we can square root this value and we get the radius. Notice that the center, there's a minus here, so the center is A, and the center y coordinate is B. So be mindful of that when we go through the problems. If you expand this then, you get x squared. The two middle terms add, you get minus 2 lots of ax, plus the a squared, y squared, minus 2by, isn't it, plus b squared when you expand that bracket. That's equal to r squared. The x squared and y squared can be put together here, minus the 2ax and 2by, and then plus a squared plus b squared, bring the r squared over to be minus r squared equals 0. So this is the general form. So it's easy to go from this form to this form, and basically from going from coordinates and radiuses to the equation and vice versa. It's all relatively straightforward. So we'll do a simple little example just to illustrate that then. So here, let's have a look at this one. So center is 3, 4, so we write x minus 3 squared plus y minus the minus 4, that makes it a plus 4 squared, is equal to the radius squared, which is 2 squared, which is 4. So that tells us then, if we want to write it more long-windedly, x squared minus 6x plus 9 here, and then we've got plus y squared. The two middle terms add up to 4y and 4y make 8y, 4 4s is 16, equals 4, and then we can just simply write x squared plus y squared here and here, minus 6x, that's that term there, plus 8y, and then we've got 9 and 16 is 25, move the 4 over, 25 minus 4 is plus 21 equals 0. So we can write it in this form as well. Now let's do the vice versa then, the reverse. If we're given this equation here, half that value and write x plus 2 squared. And then half this value, minus 3, and write y minus 3 squared. Now let's see what we need to do to this equation to get back to what we had originally. Move this 12 over there. Now when we expand this equation in our mind's eye, we'll get x squared, we'll get 4x, but we'll also get a 4, so we better counterbalance that by a 4 on this side. And similarly, we'll get y squared, we'll get minus 6y, but we'll also get a plus 9 here, so we better, as I say, counterbalance that with a plus 9 on the other side, so that they'll cancel out and leave just the 12, which is what we've got. Because we can't change the values at all, of course, can we? This is 13 and 12, this is 25. So we can see that, so here we see that the center has coordinates. This would be, plus is minus minus, so the center is minus 2. The y value is 3. Notice I took into account the minus in my mind's eye here. That's it, why it's minus minus 2. And the minus is there, so the value is 3. And the radius, there's r squared, so the radius must be 5. So it's relatively straightforward, fairly easy to go from one to the other and vice versa. So that's that little section there. Final couple of remarks then on this last page here. Finding the tangent is also fairly straightforward here. Take a circle center 1, 2 and a point P4, 6 with radius 5. So here's our point on the circle itself, and we're given the coordinates, and we're given the center coordinates of the center, and we know this distance is 5. Here we're told with this with the circle, we could work it out anyway from these coordinates. If we want to get the equation of the tangent, then we don't need to do differentiation to the equation. all we need to do is find out this gradient, which is easy to do because we got the coordinates. So we could get the gradient of CP. This tangent is perpendicular, isn't it, to this line that's a radius here. So we can, once we've got the gradient of CP, we can then, because the product is -1 between that two perpendicular lines, we can work out the gradient of this tangent. Once we know the gradient of the tangent and we know the point it goes through, it's not a difficult thing to get the equation of the tangent of P then, is it? A couple of little concluding remarks then. Orthogonal circles, these are circles that meet at right angles. So they cut each other, and we've got, like, between the centres, that angle there, that I've badly drawn there, is a right angle. That's what we mean by orthogonal circles. So they have the condition that the radius on this side squared plus the radius on that side squared is equal to, because you've got right angle triangle, the distance between the centres squared. So you've got basically, if I can just try and draw it properly, there's the first radius, there's the second. They're orthogonal circles, so they cut at 90 degrees. And so we can see that this, we can use Pythag to get this property here. So that's a property that we use when we try and work out properties of orthogonal circles. Circles that touch, well, they can touch internally or externally. If they touch internally, so I'll just do a quick little, probably another bad sketch here. You'll notice that you've got a radius here, which goes right to the outside of the circle from the center, and then the internal radius, which I'll just draw across there, but it's actually going up to this on the same line. So when you take the difference, that will be the distance between the centers, won't it? So that's the modulus of the distance. And then externally, if you have two circles, one is external to the other, there they are there, then it's not difficult to see that the two radii must add up to the distance between the centers. So those are conditions that are self-evident when you see circles. They can either touch internally or externally, and that imposes conditions on the problems that you have. The only other thing to say that in this section we use the distance between a point and a line a lot, so you need to know that formula. It's actually mentioned in the intro in parabolas, so if you want to check out that formula, it's there. But the best way to do these problems, as always, is just to get stuck into the problems themselves. So all the best in this section then, guys, and I'll catch you in the next section. Cheers!